Hey everybody, we got the last two talks of the day. Dan Sinclair is the Security Compass is the company, and the name of is it a product, the Exploit Me, or is it the name of the series? Exploit Me is the name of the series. If you guys ever done any pen testing with Firefox using Firebug or Tamper Data, I think you guys will get a kick out of this one. Also want to remind everybody about the entertainment tonight. It starts at 10. There will be free beer, as usual. So, we aim to please. Starting at 10. Yeah, starting at 10, we're going to have free beer. Going to be right out there on the patio. The freak show is actually going to be starting in here as well. They'll probably be mingling around out there doing crazy stuff as well, including the guy who said he was going to use his belt sander on various parts of his body. So this should be entertaining. Yeah. So, plus we're also going to have like chips and stuff like that. So after the final talk of the day, which is Dave Holton, go ahead and get some chow. Come on back, enjoy the party, and I'm going to go ahead and let you get on going here.
Hello? Oh, wait. So I'm Dan Sinclair, as was mentioned, and I work for a company called Security Compass. So we do a lot of application pen testing and training for developers. And one of the problems we often run into is that developers don't necessarily have easy tools to use when they're developing, and QA don't have easy tools to run when they're testing, and we don't necessarily have easy tools to run when we're pen testing. And by easy, I mean I don't want to leave my browser, right? I'm testing things in my browser. I don't want to leave my browser. So that's what the Exploit Me series is. It's tools to help us do pen testing, help developers test, help QA test. So I'm going to introduce a couple of the cool tools here. They were originally released last year at Sector. We're working on new revisions of them. But what we're going to talk through is, so the tools I'm going to talk about are one for cross-site scripting, one for SQL injection. So before I really get into that, I'm going to give you an overview of what cross-site scripting actually is. We'll take a quick look at the state of web security. Why do we care about these tools? What do they give us? What do they add, right? Then I'll introduce the two tools, cross-site script me and SQL inject me. And then I'll tell you, how you can get these tools, because they are all open source GPL. So we want people to take them, play with them, change them, give us back cooler stuff. That's what we're kind of hoping for here. And then I'll give you an idea of what we're kind of working on as the next tool that we're going to release, and some of the future additions we're going to do to these tools to make them even better. Because these are beta releases. They're not 1.0. They're, I think, 0.3 at this point. So first, cross-site scripting. Do we actually care? Isn't it just an annoying pop-up box? What's the worst thing you people can think of that I can do with cross-site scripting? Anything? Anyone think you can scan networks with it? There was actually a proof of concept released, I think it was last year, where someone was doing network scanning using JavaScript. If you can do it in JavaScript, you can do it from the browser, which means you can do it as cross-site scripting. That's pretty bad. Anyone think you can rob a bank with cross-site scripting? This isn't a real bank. This is my bank. It has a cross-site scripting vulnerability in it. Let me open it up here. I cheat and use videos. So this is my bank, the IBD bank, once he gets in there, is the International Bank of Dan Bank. And it has a cross-site scripting vulnerability. So we're just going to take a quick look. And it's a simple bank, right? It allows you to do payments, so you can pay other people. You can set up people you want to pay. You can sign up and log into the bank. So we're just going to sign into the bank here as the victim. The one caveat for this attack is you have to know that the person you're attacking is actually logged into the bank. But that's becoming a lot easier these days with things like Facebook, where people put up their status. Ooh, look, man, I'm doing my banking. Or they're on Twitter and they say, look, I just paid off my MasterCard bill. And then, okay, they're on their bank. So let me get them to do something. So we're setting up a payee, so I'm going to pay myself. I'm going to pay myself $1. You can see it just goes through, and I successfully paid myself $1. So just showing how the bank works. And I got $999 left, right? Simple bank, This could work over SSL. This example isn't over SSL just because I was too lazy to set it up. But SSL would not make a difference in this case. And the other thing to keep in mind is that if you've heard of anti-CSRF tokens, so anti-cross-site request forgery tokens, they don't help with this. Because the way this attack is working, you can actually parse those tokens out, and you can reply to them. So what we're doing here is just discovering that there is a cross-site scripting bug in the payee dropdown. So that dropdown, it's not being validated on the back end to be actually correct data, so it's cross-site scriptable, and you can see it pops up SSSB. Okay, cool. So we have a bank site, we have a vulnerability, and right now we have our user who's logged into the bank site. He has a session ID, which we need to be able to impersonate him. You know, this could run under SSL, it doesn't matter. So while he's on our banking site, we convince him to visit a malicious site. So we're going to get him to visit our super happy fun site, right? Which we can do, you know, through our own Twitter stream. And it's like, if you're doing your banking, look at my site. I've got tips on, you know, saving you thousands of dollars when you pay off your MasterCard. So they come over to our super cool site over here. And, you know, it's a fun site. You can do stuff on it. That's it, you know. It's not doing anything. It's not showing the user anything. You know, it's just sitting there. So the user then goes back to his bank account. And interestingly enough, you know, once he actually gets back there, I'm faster than he is, you'll notice he's lost another $500, which would be a bit of a surprise when you go back and look at your bank account statement and say, what? I went and saw a website, now I just lost $500. What just happened? So on the back end, that website's actually doing AJAX calls. Does an AJAX call to exploit the cross-site scripting bug, which gets the session, which he then uses to add a new payee, which he then uses to pay the payee. So the AJAX in the back end is doing all these calls to the website, parsing the results, sending more results back, right? So if we can parse this stuff, we can parse the CSRF tokens, we can parse it anything. So anything you put in your form to stop me from doing this, I can reply to it and do it again. So we've suddenly got a hacker in our pay account, which was probably not our intent. Let's get rid of that. So as you can see, cross-site scripting is actually kind of nasty. I can't talk here because I'm talking twice. So these aren't new, right? Cross-site scripting, it's been around for however long the web's been around. Same with SQL injection. These aren't new attacks. There's nothing new here. The problem is they're not getting fixed. The problem is developers don't know they're there, so they keep writing web applications with them. This year was the first year cross-site scripting bugs outnumbered buffer overflows in the common vulnerability and exploitation database. The current estimate is 85% of web applications are vulnerable to cross-site scripting. 40% are vulnerable to SQL injection. So you think of the number of web apps out there, that's a lot of sites that are vulnerable to these kind of things, right? And just as a side note, there's a site called xss.com, which gives a list of cross-site scripted sites. So these are sorted by page rank, so it's not just that Yahoo's up there a lot. But you can look at this and see, you know, we've got Yahoo. I can't actually read them, but in here there's Google, there's pretty much everyone in here you can think of. And these are, you know, PageRank 1 sites, PageRank whatever sites. And there's tons of them. Huh? No. In case you're wondering, the X's and the check marks mean the check mark means it's been fixed. X is not fixed as of whenever this was last updated. I don't know. But so these are all these cross-site scripting vulnerabilities that are in this thing. They're just out there. And these are big-name sites, right? You think Yahoo could do web security and fix the cross-site scripting vulnerabilities, but they still have these problems. So it's a big issue, right? So, hey, go away. There we go. And this is just an example of a simple SQL injection. Has anyone here read XKCD? You know of Little Bobby Tables? It's a XKCD comic where she names her son Bobby, quote, semicolon, drop table students. And the school calls her up and he says, oh yeah, Little Bobby Tables. So. So, you know, these are fairly common vulnerabilities, and that's sort of the big problem. So then what is XSS specifically? When you have cross-site scripting, you're basically dealing with unvalidated user input. So the user types something in, and we don't check it on the back end, and we're going to reflect it either to that user or to a different user. So we're dealing with that input that's not validated. It's typically JavaScript. The interesting thing is last year you could actually cross-site script PDF files because the Acrobat reader was not validating its its input so you can pass cross-site scripting through. So if you think about it, any website that served PDF files was cross-site scriptable. And if people are still using an old version of the Acrobat plugin, probably still is. And that's not a good thing, because cross-site scripting, you can steal the browser's cookie. Once you have the cookie, you have everything, right? Because typically the cookie has the session. The session is that user's credentials after they're logged in. So if you have the user's cookie, you are that user for the lifetime of that cookie. And that's usually bad. So there's two kinds of cross-site scripting. Reflected, so the user types something in and immediately a pop-up box pops up with what he typed in. Cross-site scripting deals with this right now. It deals with the reflected version. The other version is stored, so the user puts something in, saves it to a database, and then another user comes along and runs that and has something pop up on them or execute. Cross-site scripting currently doesn't deal with stored cross-site scripting, specifically because you then have to start spidering the whole website and figuring out where can this show up, and it's sort of a big, difficult problem that we haven't took out yet. We want to do it, we just haven't done it yet. And the last thing that you sort of noticed in the attack we did was AJAX. So AJAX is asynchronous JavaScript and XML. AJAX can pretty much do anything. It can send data, it can receive data, it can parse data, it can do anything, which makes it fairly powerful when you combine it with these cross-site scripting and other sort of vulnerabilities, that you can do a lot more stuff. And that kind of makes it scary. So we're not trying to say that we invented the idea of, testing for these things. There's lots of great tools out there. Tamper Data is a great tool. Fiddler is a great tool. There's all these great tools, There's all kinds of open source tools. There's commercial tools too, if you can afford the commercial tools, because they're typically not cheap. The problem we have with these is that they're heavy. And by heavy, I mean you have to start up an external process. You have to configure your browser to proxy to that process. When you're done your testing, you change your browser back. I was a developer. I was too lazy to do that kind of thing, right? You're not going to want to do it. These tools take too much effort. And if you kind of look at it, that's not a simple interface. So they require a certain amount of domain knowledge to start using these tools, which you may not have in developers or in QA. So that's where we sort of saw this missing piece. So most tools that are developed aren't for developers, they aren't for QA, they're for pen testers. Pen testers come in, they run these tools, they know what they're doing, they know how to use them. We want to see developers fix their tools. We don't want to go in for a pen test and find cross-site scripting, because it just kind of makes us think, oh, okay, we found cross-site scripting, let's move on. We want developers to fix it earlier in the development cycle. We want QA to fix it. We want to give them the tools that they need to fix these things. And to do that, we have to make it really simple for them. So we're trying to push it earlier into the SDLC cycle. So that's where cross-site script me comes in. Cross-site script me is a Firefox extension. You download it, it comes off our website, installs into Firefox. And then when you want to use it, you just open it and run it. So we'll actually go over here and find my mouse. So this is a demo site. It's not a real site. It's actually for testing for things. But I can come over here and I can open up XSS.me if I could see. So it just opens up in a little sidebar here. And the thing you'll notice is that down in the corner there, you'll see our form. So that's the one form that's on this page, which is this search form. And in that form, we have one text box and one go button. So cross-site script me goes through the web page and finds all the forms on the site. It will find all the hidden values, all of the input fields, all the drop-down boxes, all that kind of fun stuff. And then it lets you inject cross-site scripting vulnerabilities into them. So yeah, I can run this. I'm actually going to just do that one and find my window. So it goes off and run. I think I clicked on the right button. Yeah, with top attacks. So top attacks just runs 5 attacks in my case, because I don't run them all, because it's it's going to run actually 16 attacks in this case. So it isn't just the number, it's a multiplication thing that I can never remember how it works. But it goes off and it's probing for vulnerabilities, and I'll talk about our heuristics that we stuck in with the latest release to make things a bit faster. And then once it's done that, it figures out, okay, given what's on there and what I can exploit, I'm going to run a certain number of tests. And it's going to run 10 tests in this case. So you can see a whole bunch of tabs popped up in the background. So it uses the tabs in the current version to execute different pages. So don't actually change tabs when you're running this, or it will get all screwed up. It needs to know the main page to keep going. So those things will pop up, and they'll all eventually hopefully go away, and you'll see this results page pop up. So you'll notice first off that there's these fields here, and this one's marked all red, and this one's marked green. The reason this one's red is because our heuristic testing has told us that none of these things get through, and we'll discuss that in a little bit. Whereas in this case, everything gets through on that field. If everything can get through, that means I can send my cross-site scripting characters through, and maybe they're reflected back. And I can see here that in one case there is a failure in that it does allow me to run cross-site scripting. And so you can see there's red, yellow, and green. And we'll talk about what that means in a minute. But basically, it's this actually ran, this might run. So we know that this runs. So we know that if we put in the script tag into that field, it's cross-site scriptable. And we'll talk about what document.vulnerable equals true is in a minute here. This one is a little bit different in that it could be a vulnerability. And that's because we don't necessarily know. And we'll get to that. I'm going to get to a lot of things, apparently. So let's take a look at some of the options on this thing. It's very hard to see options. So there's lots of options you can do. So I mentioned the preferred number of attacks. So that's actually configurable. In my case, I do it to 5. So the reason we have that is because if you run all the attacks, that can take a long time because you can have a lot of attacks in the system. You can have 120, 130 different attack strings. So maybe your developers are commonly susceptible to 5 of them, right? So you can configure this thing with those 5 attacks as the top 5 attacks in your list and tell the developers, just run these 5 attacks. It takes 30 seconds. Whereas if you run all the attacks, maybe it takes an hour. So you can have your developers go off and configure this to have those certain number of attacks. The other thing you have is the number of tabs to run in. The more tabs you run in, the more memory you need. So it's all based on your system. You got more memory, use more tabs. Makes it faster, sucks up more memory. Heuristic testing is configurable, so you can actually turn it off if you want, and you can configure the characters you send through. The thing with heuristics is it's not in the version that's on the website now. It's in the one that we're going to release. So it's in 0.3. It's coming. It's not out quite yet. And that last option you could ignore because even I don't know what it does. The developer put it in. This is what we get for letting developers put stuff in. And the other one we have here is the strings. So this is our list of cross-site scripting strings. This list comes with basically the complete list of RSnake's cross-site scripting vulnerabilities. The ones that are missing are the specific ones that reference an external website. We didn't want to put them in because we didn't want people to think we were tracking their execution of cross-site scripting. So we have those available, and you can see we have import, export, add, remove, up, down, so you can modify this list. So we've made those extra attacks available off our website, and the JavaScript file you need is available, so you can download that and put it on your website, modify it, and put the attack string in here so that we don't know that you're running the tool, because you might have a customer that you're running it against, and you don't want us to know who your customers are. Some people are very paranoid. And you can see each one of these attacks has document.vulnerable equals true. So that's sort of how this thing works. Okay. Okay, so heuristic testing. So the thing we have is if you run all of these attacks, it takes a long time. Trust me, I've done this. It takes a long time. So we sat down and we thought, okay, how can we make this faster? And we realized that there's certain characters that all of your cross-site scripting attacks typically use, right? You'll typically have an arrow bracket or a quote or a semicolon or something. There's a typical set of characters. So why don't we inject all those characters to begin with and see which fields send them back unencoded. If we get those characters back unencoded, we can theoretically cross-site script detect that field. So we just use this heuristic testing to try and determine which fields we can completely ignore straight off the gate. My laptop is so slow. Yeah, I know. It's not my choice. Are you changing? No. Oh, there we go. So how does this work? You notice that we had document.vulnerable equals true. So what we do is when the page starts to load, the script modifies the DOM and inserts this document.vulnerable equals false tag into the DOM. So when the page loads, if the JavaScript gets executed, the DOM will change and that will be set to true. So we can tell that that JavaScript was executed because our document.vulnerable is now equal to true. So if you want to write your own sort of attacks to put into this thing, all you have to do is set document.vulnerable equals true. You can have your own. So the problem is this doesn't always work. There's specific cases where the JavaScript won't get executed in Firefox or won't get executed when the page loads, but we still want to be able to catch those. One of them is on mouse over. So if you have an input value that the user types in, and you're putting it back into, say, an input box, what happens if the user puts in close quote, space, on mouse over, quote, execute JavaScript? That's not going to run when the page loads. It's only going to run when the user mouses over that text box. So what we also do is we send 2 requests for every page. The first request comes back, and we render it in the browser. If it renders in the browser, we know for sure you're vulnerable, so we mark it red. The second request we send out, we get back to plain text. We then parse that plain text and look for the attack strings in that plain text as exact copies of what was sent in. If that comes back, you're probably vulnerable, but we don't know, and that gets marked as yellow. So it tries to sort of detect the different possibilities for things that aren't available in Firefox or wouldn't execute on page load. So, whoa, that was interesting. Oh, no, it wasn't. I can't read. Thank deity for struts. Struts is supposed to be the be-all, the end-all to save us from ourselves and keep our kittens out of the tree. You know, people tell us if you want to be secure, use struts, which is probably a good idea, right? Frameworks give you lots of fun stuff and can save you a lot. The problem is you probably don't want to follow the actual struts examples. So this is the struts examples that they ship with you. And so we can actually go into the upload properties one, and we'll just run cross-site script me against it. And the problem is it's actually vulnerable. So they're shipping these, which developers will take, copy into their web application for how do I do, file upload, and it's cross-site scriptable. And this is a problem because the examples we're telling our developers how to develop with are cross-site scriptable. So you have to be very careful, even when you're dealing with code that someone's told you is, this is the perfect, it will solve all your cross-site scripting problems. It's not necessarily true. And this is what causes our developers to have, of course, cross-site scripting vulnerabilities, because they don't realize that it's actually vulnerable. So the second one we're going to talk about is SQL injection. So SQL injection is similar to cross-site scripting, but we're dealing with SQL, and specifically usually dynamic SQL. So we have an SQL statement here, and you'll see we're inserting the username and password values that the user typed in. This is well and good when the user types in normal values. The problem is what happens when I come along and put in or 1 equals 1. 1 equals 1 is always true in a database. I've closed the quote, so I'm extending the database statement and adding an extra statement that always evaluates to true. So it's going to return back every single row in my database. So it's always true. So I can now log in as Jimmy because it's always true. So this is actually another common one that developers do. The amusing part about this one is the solution is actually well known, and it's faster than what they're actually doing. So the solution is to use prepared statements or stored procedures. Stored procedures you can actually get SQL injection in, but it's only in certain cases. But using prepared statements pretty much is a fairly good solution to this problem. Developers just don't know to do it. So they keep using dynamic SQL, and they keep having these same sort of SQL injection problems. So that's why we came up with SQL Inject Me. And we'll go and look at our thing here. So we'll go back to our test website here. And the login form I happen to know is SQL injectable. So I'll actually show you the options on this because I changed it slightly. So similar to cross-site script me, we have a set of options for SQL Inject Me. I'll skip over most of them right now. But the one to notice is down here, I've put hello into my result strings. The thing with SQL injection is possibly a correct result, or sorry, you could be vulnerable to SQL injection and the vulnerability actually ends up in your website working correctly. So we can't actually tell necessarily when your SQL injectable. So by default, we just put in a couple database errors. I believe the version that I don't have installed right now has like 6,000 database errors or something crazy input into it. But in this case, I just put in hello. The reason I put that in there is because if you successfully log into this Altamira website, it will say hello user, so that you know that you're logged in. So I can come back to SQL Inject Me, and you'll see there's two forms here. This is the search form, and there's the login form. So I only really care about the login form. So I'm going to pick these two fields of the login form, and I'm going to run my top 5 attacks. So it goes off similar to XSS Me. There's no heuristics in this because we weren't sure, what characters to deal with or if it would even work as well. So we just run the SQL injection attacks. In this case, you can see it's running 36 attacks. It will chug along. Similar tabs popping up in the background. Eventually, hopefully, yes, there we go. So we can see that it's vulnerable to 7 attacks. So you can see there's sort of all these list of attacks down here at the bottom that password field is vulnerable to. So we could pass any of these through, and we would log into the site. You'll notice one of them should be my error. Yeah, see, so empty string found hello, or error string found hello. So this is the case where it actually logged into the site. These ones you can see it was a database error, so we sent something in and the database said, I don't understand that, and blew up. In the last one, it was actually the site working correctly. So if we hadn't have put that hello string in there, it wouldn't have known that it was vulnerable. So SQL Inject Me does take a bit more thought on your part of, if they correctly inject the website, what's going to happen? So that's why we sort of allow you to enter in these extra error strings. Okay, I think there aren't, okay, I'll actually take a look at it. So, yeah, you can see it's similar to cross-site scripting in that there's import, export, you can add, remove, move up and down, and there's a whole list of SQL injection strings. So if you have other strings you want to add, you can add your own SQL injection strings into this thing, as you need to modify it. You can export them into an XML file and run over the XML file with whatever you want. I apparently talked really fast this time. Okay. So where do you get these tools? They're available off our website, securitycompass.com. That's the same place the extra attack tools are available. So you can log on there and download the extra attack tools to import into your attack list for XSS Me. And you can grab the JavaScript file off of there as well and change it to point to your website as opposed to ours. They're open source, GPL version 3. So take them, download them, modify them, play with them, do what you want with them. And if you try to run in Firefox 3, it will blow up. It doesn't work right now. Firefox 3's APIs change so much that they just don't function. We figure we'll deal with that when Firefox 3 is actually released, whenever that date finally comes around. We'll get a new version of it then. But we figure even then, a lot of developers, pen testers, and QA will still be running Firefox 2. We can't see the uptake being so enormously fast that we're going to break our tool in Firefox 2 to switch to Firefox 3. So we're sticking with 2 for now. So what are we doing now? Well, XSS Me and SQL Inject Me version 3 are coming. That was the version you actually saw. It has the heuristic attacks. It's faster, uses less memory. I'm not exactly sure when they're going to be released anymore. They keep changing the date on me, so I can't tell you the exact date. We want to eventually add auto-encoding. So the problem is we're only ever sending everything through an ASCII. We want to be able to send it through in different character encodings. We haven't done that yet. It's planned. It's also kind of difficult. As I mentioned, we only do reflected cross-site scripting. We want to add stored. In order to add stored, we have to start crawling the websites or getting some kind of user-directed input in how we should find these pages where it can be reflected onto, which is also sort of a fairly large and complicated thing. And a new tool that we're working on is called Access Me. So what Access Me does is it runs along, you start it up as you're browsing a website. It runs along with you. And as you navigate to each page, it will do a second submission of that page and remove your cookie. So it tries to check which pages on my site can I actually access unauthenticated when I shouldn't be able to. So it runs along and checks all these accesses for you in the background. And when you're done, I think he's setting it up so you hit a button and it generates a report and says, I can get to this page and this page and this page unauthenticated. You know, is that a problem? So it tries to help you determine in your website if you have these sort of access violations. So that's actually the end, and I have lots of time for questions. Yes?
Are you looking at any timing attacks based on SQL?
Timing attacks, yes. Are we looking at any timing attacks based on SQL? That's actually come up in a couple of conferences. People keep bringing up blind SQL injection and using timing attacks on SQL. We think it's a great idea. We haven't had time to look into it yet. It's certainly on our list of things we would like to do, but we don't know when. So if you feel like doing it, we'd be quite happy to accept the patches. Anyone else? Okay, I guess that's it then. Thank you.